Alright, let's get right to it. We're on day number 9. We have a large circle with a diameter of 20 feet, small circle with a diameter of 6 feet. What is the area of the unshaded part? So we're looking at this big circle here, but we don't want this piece in the center that is shaded. So how can we figure that out? Well, since we're talking about area, we know we're going to need the area of the whole thing. So we're going to need the area of the large circle. And we're also going to need the area of the smaller circle inside of it. And then we just have to think, what can we do with those two numbers? So area of the small circle. Well, if we consider that we don't want the small circle, we can say, well, what happens when we take it away? If we just subtract it, we should get the area that is unshaded. So let's just get right to it. So we know that the diameter of our big circle is 20 feet. So let's find the area of that. We know area of a circle is pi r squared. And for the sake of this, since we don't really need to know it just yet, let's just leave pi as pi. Okay? And our radius, if the entire distance across is 20, then our radius would be half of that. So what is half of 20? That's just 10. So that'd be 10 squared. So now we can do the math. I still want to just leave pi as pi, and we're going to see why that's going to work out in a second. 10 squared, or 10 times 10 is 100. So we have the area of our bigger circle is pi times 100, or 100 pi's. Okay? And so now let's find the area of this inside circle. Well, we know the diameter of this is 6. So again, we have area is pi r squared. Since we have a diameter of 6 here, again, we need half of that for the radius. So we're going to say the radius is just 3. So it'll be 3 squared. And just like we did on the other one, we're just going to leave pi happy as pi. If we work this out, 3 squared is 9. So the area of our smaller shape, or smaller circle, is going to be pi times 9, or 9 pi. And so now we said we wanted to subtract these two. So what is going to happen if we take 100 pi and we subtract 9 pi from that? Well, that's just going to be 100 minus 9. So 100 minus 9 is just 91. So what is the area of the unshaded? It is 91 times, and pi is still here, so 91 times pi. And then just real quickly we can figure out, and let's just use 3 for pi, just so this doesn't take forever. 1 times 3 is 3. 9 times 3 is 27. So about what is the area of our unshaded area? It's about 273 feet. Since this is area, that would be feet squared. Okay, and that's it. You would have gotten this exact same answer if you'd used pi in the beginning. It's just a little bit simpler to save it for the end. Okay. Alright, oh wait, before we go, I don't know if anyone else noticed, but this circle within a circle just absolutely reminded me of Cookie Monster and his eye, and I wonder how we ended up with Cookie Monster's eye on that problem. A little creepy. Okay, number 2, Cookie Monster's eye. 28% of people said they made a different New Year's resolution each year. If you polled 500 people according to that, how many would indicate they made the same New Year's resolution? So this is what we want to know, and this is what it tells us. 28% made different resolutions. So how can we figure out what percent made a new one? We start with the total would be 100%. And if we take away all these people that said they made a different resolution, that should leave behind all the people that made the same resolution. So 100 minus 28 is 72%. So that's only part way, because we want to know how many people out of 500 is that. So now we're comparing people to this percent. So we're comparing two things. That's proportion. So we can say the same, if we need a key here, the same resolution. And let's compare that to the total, because anytime we have percents, we can talk about a total. And we can say our total percent is 100. The percent that had the same resolution, we figured that one out, that's 72%. And let's see, so we don't know how many people made the same resolution, but we do know that there were 500 people in total that got asked. And so here is our proportion. So we could cross multiply this, and there are some pretty good sized numbers in here. This might take a while. Or we can consider this relationship between 500 and 100. We can think, how can we get from 500 to 100? Is there some number that I could divide 500 by that would give me 100? Well, there's 5. 500 divided by 5 is 100. Don't believe me? 500 divided by 5, there it is, 100. So that means I can take our mystery number x. If I divide that by 5, it should give us 72. Since I don't know what that mystery number is, I can actually work backwards. Instead of saying dividing some number by 5, I can say 72 times 5 gives us some number. Just like down here, 100 times 5 gives us 500. So let's figure out what is 72 times 5. This will give us 0, or 10. 5 times 7 is 35, plus 1 more is 360 people. So how many people said they had the same resolution? 360. Now if you didn't catch this relationship, you could always cross multiply and then divide, and you would get the same answer. This is just, I don't know, this seems a little bit simpler, and that we don't have, it's one step. We did one operation, we had an answer. 1 is less than 2. And as long as we're talking about New Year's resolutions, let's take a look at what people's resolutions actually were. So, did some digging. The University of Scranton, which I think is in Pennsylvania, they asked people, they asked, what was your resolution? And they came up with a top 10 list. So let's do this all David Letterman style. Okay, number 10, spend more time with family. That's nice. Number 9, fall in love. Aww. Number 8, help others in their dreams. This is like Inception stuff, to help them in their dream. That's cool. Quit smoking at number 7, always good. Don't smoke. Number 6, learn something exciting, like math. Obviously would be something exciting to learn. Number 5, staying fit and healthy with math, obviously. Math. Alright, we're getting to the good ones now. Number 4, enjoy life to the fullest. And I'm just going to drag this up here with math. Spend less, save more. That's kind of boring. Number 2, getting organized. That's boring too, huh? People are boring resolutions. And number 1, to lose weight. That's actually pretty good. Alright, so there's your list. Maybe you're somewhere on that list too. Okay, number 3. Joe has a thermos with a radius of 4 inches and a height of 10 inches. How many cubic units of water are needed to fill the thermos? So thermos, some people might not be familiar with what that is, so here's a quick little Google image search. Thermoses are just something you use to keep cool drinks cool, warm drinks warm, put like soup and stuff in it, come with like cute little pictures or whatever you want. It's a pretty big company. Alright, there it is. Oh, here's Dora. Everyone likes Dora. Okay, so that's a thermos. Big idea is that it's a cylinder. Even if you didn't know that, the fact that it says radius and it says cubic units, that means it's a three-dimensional figure with circles. And so we're going to assume this is a cylinder. Let's draw ourselves a cylinder. And we know the height of this is 10 and the radius is 4. So we need cubic units. We're talking about volume. So we have a formula for volume that always looks like area of the base times the height. Our base on this is a circle. So we know to find area of a circle is pi r squared. And all that is times the height of the shape, the cylinder. So now we can fill in our numbers here. So we can say that pi is, and let's just use 3, because again, I don't want to take all night multiplying. Our radius is 4, that's 4 squared, and the height of our prism is 10. So really what we're looking at is 3 times 4 squared times 10. This just becomes an order of operations problem. We have to do the exponent first, so 4 squared is 4 times 4 is 16. So we have 3 times 16 times 10. Now it's all multiplication. We can multiply this any way we want. Let's do 3 times 16, which is 48. And 48 times 10 is 480. And that is inches cubed. And there is your volume. So how much water would it take to fill up our thermos? It would take 480 cubic inches. Okay. Alright, number 4. Two triangles are similar. There's that word again, similar. Hopefully we're starting to get the pattern of that. We have a larger one. We have a smaller one. So let's draw ourselves two triangles. Whoops. No. Uh-oh. Okay, we're back. That was scary. Alright, so we need two triangles. And they should be similar, so same shape but different size. Say the larger one has a base of 9 and a height of 12.5. So our picture isn't the most accurate, but that's okay. The smaller one has a base of 3. What is the smaller one's height? Okay, so we have that. We can call this large. And we can call this small. And we can just make a proportion of this. Remember, anytime we talk about similar figures, always proportions. Large to small. And we can fill in some side lengths here. We pick a side from the large shape, our large triangle, we can say 12.5. What does that correspond to on the smaller shape? That's the left side, it's the same as x. We pick a second side from the large triangle, we get 9. And a second one from the small one, which is 3. And there's all sorts of ways we can do this, but let's just, for the fun of it, let's cross multiply. Let's not do anything fancy. 12.5 times 3. We're going to get 15, 1, that's going to be 7, 3. With 1 decimal place, we get 37.5. We're going to take that and divide it by 9. So we say, what is 37.5 divided by 9. Well, 9 will go into 37 3 times. Wait, that's not right. Because 3 times 9 is 27, but 4 times 9 is 36, and that's still less than 37, so that'll work. 1. We bring up the decimal, bring down the 5. 9 will go into 15 once. 1 times 9 is 9. And this might go on for a little while. We'll just do one more decimal. So 9 will go into 60. 9 will go into 60, what, 6 times? And 6 times 9 is 54. And we could keep going, but let's just leave it. Let's leave it at that. So this is going to be about 4.1 centimeters. Okay. And hopefully some of you notice, well, this side here is 3 times as big as that side, so shouldn't this number rather, be 3 times as big as that? And let's see if that's true. Let's bring up our calculator here. Let's say we said it was 4.16. If we do that times 3, we get 12.48. And obviously we're not going to get it exactly because we didn't go through all the decimal places here, but we see that that's relatively the same. So if you pick that up, that's very good intuition on your part. If you understood this, that works too. As long as you're getting something out of it. All right. And number 5. Name the following triangle according to its angles and sides. So we have a triangle. And let's see. It should look something like this. So we have our angles and we need to name him. I will name him Billy. Alright. All kidding aside, this needs a mathematical name. Looking at our angles, we have an acute angle, an acute angle, an acute angle, which makes this a very acute Billy. And we'll let Billy talk. So Billy's acute, and what about those are the angles. What about the sides? What can we say about our sides? Well, if 2 of our angles are the same, then that must mean that 2 of our sides are the same as well. Because if this angle is the same as this angle, that means that this side here has to be the same as that side there. So if 2 sides are the same, it has to be isosceles. I hope I'm spelling that right. Isosceles. So what kind of triangle is this? It is acute, and it is isosceles, and it is Billy. Okay. That's it. Good job. Good night.